Over 390 million miles from Earth lies one of the most extreme and chaotic roads in our solar system, Io, Jupiter's most violent moon. Unlike most moons that are frozen and geologically dead, Io is alive with fire. Its surface is constantly reshaped by explosive volcanoes and lava flows. But what makes a place like this so far from the sun, so geologically active? What's powering all this volcanic fury? In 2023 and 2024, NASA's Juno spacecraft performed a series of close flybys of Io, getting as close as 930 miles from the surface. These encounters gave us the clearest views yet of Io's rugged terrain, its volcanic plumes, and even mountains never seen before. Let's explore what Juno and all other spacecraft uncovered. You're watching Kyanite. Across the solar system, more than 280 moons orbit the major planets. Each is fascinating in its own way, but none compared to Io. This moon isn't just unusual, it's a glimpse into what the early solar system might have looked like. A world still driven by the chaos of its formation. Io is the most volcanically active object we know of. It has more than 400 active volcanoes erupting across its surface. Lava fountains soar into the sky. Massive calderas stretch for hundreds of miles. Lakes of molten rock bubbled just beneath the crust. Io is roughly the same size as Earth's moon, about 2,260 miles across. But unlike our moon, Io is constantly changing. There are no icy poles, no signs of liquid water, no stable atmosphere. Most of what we know about this bizarre moon came from NASA's Galileo spacecraft, which studied the Jupiter system between 1995 and 2006. Later missions like Cassini and New Horizons make quick observations as they passed by. But now, Juno is still orbiting. Jupiter continues to show us just how extreme Io really is. So what makes Io such an incredibly volcanic place? The answer lies in gravity. Io is locked in a constant gravitational struggle between Jupiter and its neighboring moons, Europa and Ganymede. As Io orbits Jupiter, it's pulled and flexed by these competing forces, like squeezing a stress ball over and over. This constant flexing creates massive internal friction. That friction generates heat, enough heat to melt rock and keep Io's interior in a near-constant molten state. That's why Io's volcanoes aren't powered by tectonic plates like Earth's. Instead, they're driven by tidal energy, Jupiter's immense gravitational grip heating the moon from the inside out. Io's eruptions are like nothing seen on Earth. Entire regions are resurfaced by lava flows. Impact craters are rare because they are constantly erased by molten rock. Temperatures near these volcanoes can reach over 2,400 degrees Fahrenheit, while the average surface temperature is a freezing -22. Juno's microwave radiometer allowed scientists to peer through Io's crust and collect thermal data. What they found was surprising. Io's surface is relatively smooth compared to the other Galilean moons. Lava is constantly covering older features, erasing craters, filling valleys, and leaving behind glossy glass-like plains. Pele was one of the first volcanoes discovered on Io. Back in 1979, Voyager 1 spotted a huge volcanic plume at Pele, reaching up to 190 miles high. Pele is also known for the large red ring surrounding it, caused by sulfur falling back down from the plume. This streaking ring makes it one of the most recognizable features on Io. Later, NASA's Galileo spacecraft took high-resolution images of the area, revealing a complex hotspot. Parts of the lava lake there appear to glow in the dark, with fresh sections of crust breaking and overturning, showing that Pele is still very active, and Pele isn't alone. In 2007, the New Horizons spacecraft passed by and caught one of the most dramatic volcanic events ever recorded on Io. It captured a massive 200-mile-high plume erupting from a region called Tvashtar Petri, an eruption that lasted over 530 days. A sequence of photos taken over 8 minutes shows volcanic debris hanging above the moon's surface. Additionally, among Io's most famous features is Loki Patera, a vast volcanic depression roughly 125 miles across. It's filled with a huge lava lake rimmed by molten rock and dotted with island-like peaks. Juno's high-resolution images revealed reflective surfaces across the lake, indicating that parts of it are as smooth as volcanic glass. Infrared data collected by GIRAM, originally built to study Jupiter's auroras, has proven invaluable for studying Io's volcanic activity. This graphic shows the infrared radiance of Chor's Patera. The white ring indicates where lava from Io's interior is directly exposed to space. The area in green outside the lava lake is very cold. To better understand Io's volcanic landscape, NASA scientists combined infrared and visible light images from 2 Juno flybys in 2022 and 2023. They created a heat map showing intense hotspots across the moon, marked in red, yellow, and white. Each pixel represented an area up to 12 miles wide, revealing vast lava fields glowing with heat. While most attention goes to Io's volcanoes, this moon also features colossal mountains. Unlike Earth's mountains, these aren't formed by tectonic plates. They're isolated and jagged, likely built up from its internal pressures and reshaped by volcanic activity. You can find mountains that are even taller than Mount Everest on Earth. One of them is called the Steeple, a sharp-like peak that rises between 3 and 5 miles high. Thanks to data from the Juno mission, scientists were able to create 3D models showing what this and other giant peaks might look like from the ground. Another massive mountain on Io is Euboea Montes. It stands about 10.5 kilometers tall and was likely formed when a block of Io's crust tilted and later collapsed in a huge landslide. And then there's South Busol Mons, the tallest mountain on Io, one of the highest in the entire solar system. It stretches about 145 by 159 kilometers, and its height between 17.5 and 18.2 kilometers, more than twice the height of Mount Everest. Its landscape is covered in vivid alien colors, yellows, reds, greens, and whites, painted by extreme heat, powerful eruptions, and strange chemical reactions. These colors aren't just for show. They tell the story of what's happening on and beneath the surface. Yellow covers much of Io's plains and volcanic regions. This color comes from solid sulfur that's been ejected during eruptions and then cooled as it settles. It forms a dusty coating over everything nearby, giving large areas of the moon a yellowish hue. Red and orange mark areas of recent volcanic activity. These fiery shades appear where hot lava lakes have opened up or where fresh eruptions have occurred. The intense heat causes different sulfur compounds to break down and react with the thin atmosphere, leaving behind chemical stains that show up as vivid reds and oranges. White areas are made of frozen sulfur dioxide in colder regions of the moon, farther from active volcanoes. This gas freezes out of the atmosphere and settles on the ground as frost or ice. It reflects sunlight, making these patches appear bright white in images. Green is one of Io's more mysterious colors. It's seen in scattered patches and streaks, and scientists believe it might be caused by unusual sulfur compounds or possibly chlorine-based chemicals reacting with intense radiation from Jupiter's magnetic field. These reactions may alter the surface chemistry in unpredictable ways, creating strange greenish tint. Despite the hellish conditions, Io has a thin atmosphere made mostly of sulfur dioxide. It's so fragile that it collapses when the moon falls into Jupiter's shadow, freezing and falling back to the surface. But during active eruptions, volcanic plumes release over 4 tons of gas every second. A 1998 image from Galileo taken during an eclipse captured Io glowing in greens, reds, and blues, each color tied to a different gas. Io may be one of the most hostile environments in the solar system, but it's also one of the most fascinating. Juno's recent flybys have shown us a living world erupting, evolving, and glowing in real time. With each new pass, we gain a better understanding of how tidal forces shape worlds and how moons like Io challenge our assumptions about where activity can happen in space. If you want more videos like this, subscribe to the channel. See you next time.